Okay, for question number 27th, part A, we have to find the intervals in which the function is strictly increasing or strictly decreasing. And our function is f of x is equal to log x by x. So let's differentiate this with respect to x first. So differentiating with respect to x. So differentiation would be which is f dash x, and we are going to use the product sorry quotient rule here. So this is v into differentiation of u, which is 1 by x, minus u into differentiation of v, which is 1 on v square, which is x squared. So now the differentiation is f dash x is equal to 1 minus log x upon x squared. Now let's find the critical point. So for maxima or minima, or for the increasing or decreasing function, f dash x should be equal to 0 for increasing or critical value. Let's find out the critical value of x. This f dash x should be equal to 0. And if you put f dash x is equal to 0, this is 1 minus log x upon x square is equal to 0, which gives 1 minus log x is equal to 0, or log x is equal to 1, which gives x is equal to e raised power 1. So that means our critical value is x is equal to e. Now let's find out the interval in which this function is strictly increasing. Now for strictly increasing function, f dash x should be greater than 0. So f dash x is, this is 1 minus log x upon x should be greater than 0. So this is 1 minus log x is greater than 0. If we take this to the right hand side, this is 0. So this gives us 1 is greater than log x, or log x is less than 1, or x is less than e. Okay, now x is less than e, and we know that the value of x is 2.17 something, 2.71. So this is value of e is 2.71 approximately. And to make sure that f dash x, this f dash x is 1 minus log x upon x squared should be greater than 0. Now for strictly increasing, this should be greater than 0 and x should be less than 1. So this x should be less than e, that is 2.71. And but x can take only the positive, log x can take only the positive values. It has only the positive values. And for that, our x should also be greater than 0. Okay, so x should be greater than 0 and x should be less than e. So that means in, and it should not be equal to 0, because if I put this x 0 here, this becomes 1 upon 0, which is undefined. So it should not be equal to 0 and should not be equal to e. So that means for strictly increasing this function, for strictly increasing, x belongs to the open interval e to 0, or it's from 0 to e. So in this interval, the function is strictly increasing. Now let's go for strictly decreasing. Now for, let's find out the interval in between which this function is strictly decreasing. For strictly decreasing, this f dash x should be less than 0. So if it's less than 0 and our first order differentiation is 1 minus log x upon x squared is less than 0, which gives us 1 minus log x is less than 0. So this is now 1 is less than log x, or log x is greater than 1. So that means x is greater than e. Okay, so x is greater than e, so that means in the open interval from e to infinity, function is strictly decreasing. So it's decreasing in this function e to infinity and increasing in the function 0 to e.